did. They spent a couple days doing it by hand, and we're going to go straight there of how to do it with the graphing calculator. It's not a disadvantage. It's just trying to conserve time. Okay, I don't know what that is or why I got it now. Okay, I need help with your first math workshop problem.
Oh,
Yes, Daniel.
27 y to the 5th.
Did you just say 27?
That's 36.
Okay, good, because it should be 9 times 4, because the square root of 16 is 4. Y to the 5th, z square root of z.
That's what I said.
So it's 36, y to the 5th, z square root of z. You said most of it correct, we'll give you the point. Number 2 is a nice one. Volunteers to number 2. Someone besides Daniel. Okay, go ahead. I pray to God you understand this, because we've done 1,000 of these, and there's eventually a math workshop test. How many of these do we have to do? I'm needing 2 numbers that multiply. One of them needs to be a perfect square.
Okay, Dad, it is. Okay, it's 7j to the 8th power.
What are you looking at?
Number 12.
7j to the 8th power over 2.
Huh?
What?
Never mind.
Okay. What times what is 98? One of them needs to be a perfect square. 12 is not a perfect square.
4.
9 is a perfect square, but 9 doesn't go into 98.
Type divided by 2.
2 is not a perfect square.
Oh my God.
3, 4, 4.
You're just saying random numbers, and a lot of those aren't perfect squares, so I cannot.
49.
49 times what?
2.
It is 49 times 2. Literally, just trying to pick 2 numbers that multiply to 98. One of them needs to be a perfect square. Hopefully the largest perfect square possible. And we did. The square root of 49 is 7, so it comes out of the house. The 2 remains under the house.
That's what Karen said.
Shh, I thought, but then I got confused.
She said 7j to the 8th.
Yeah.
And then she said divided by 2. And it is j to the 8th. Well, your group's going to get the point anyway, because you're the one who's finally satisfied me. But no, I just, no.
She did say 7. No.
She said 7 and 2 and a lot of other stuff in between.
That's what I said.
Okay. 13 is finally not simplifying a radical. Instead, it involves rules of exponents that you're already supposed to know. And they have the same base. What are you supposed to do to the exponents? So you're supposed to get x to the perfect. Ellie gets the point. Next one, we still need to add y to the. Nick gets the point. Next one, 8 to the 9th. Daniel gets the point. And then last but not least, we're dividing. So we're going to subtract. So we'll get a to the negative 2, but that is not the final answer.
1 over a squared.
You have to put the negative in the denominator. We do not have negative exponents, so you punish them and put them in the denominator. So it's 1 over a squared. Daniel gets another point. We're going to save the last 2 for tomorrow. I'm praying he was kidding, but for reals, you know eventually you have a math workshop test. So if you've yet to figure out what's going on, you need to ask somebody or come to zero period or do some sort of SOS because it is coming. Speaking of things that are coming, before we start going on to the notes, let's talk about that perfect cubes test coming up. We're going to do it next Tuesday. It is going to have a time limit. I haven't decided how long. Can't be that long. There's only 10 of them. We are going to recite 0 through 3 today just to show me that we at least know those. What is 0 cubed?
0.
What's 1 cubed?
1. Whoa.
1 cubed is 1. 2 cubed?
8.
3 cubed?
27.
Okay, if you didn't know 0, 1, 2, 3, you're already in trouble. We've got to know all the way to 10. They're not going to be in order. So if Anne-Marie doesn't understand 2 cubed is 8, memorizing the order 0, 1, 8, 27 is not going to help her at all. At all. Okay, moving on to the notes. We are going to talk about quadratic functions. You already discussed these with your algebra 1 teacher. Goodness, I'm algebra 2. You already discussed these with your algebra 1 teacher. You've just sadly forgotten, which is sad because they are one of the most important kinds of functions. No one ever forgets linear. Everyone always forgets quadratic. In a quadratic function, The greatest exponent is a 2. That makes sense. They have 3 terms. The first term with the x squared is called the quadratic term. The term with just an x is called the linear term. And the term with just a number, as always in life, is called a constant term. You don't have to actually know that each, like the first is quadratic, the second is linear, the third is constant. I've never actually heard anyone ask that before. I would be surprised if that makes the next test. It shouldn't, but I don't make them, so anyway. This should, though. The graph of a parabola is called the graph of a quadratic function is called a parabola. I said the answer myself. How funny. Parabola reminds me of bowl, which makes sense because a parabola's graph kind of looks like a bowl. If you put food in it, it looks like it could hold it. Here's my food. And like with a linear function, and like with any function, if you have a list of ordered pairs, you can just plot those points, connect the dots, graph your function. That always works. We're going to talk about the key features of a quadratic function today. There's one other key feature we're not going to deal with today, but I swear it's coming. So if you're worried about the x-intercepts, don't worry, they're coming. Okay, so we're going to talk about a y-intercept, which is where our graph crosses the y-axis. And if you want to figure out the y-intercept, I know that ordered pair is going to be, I know the x value. What's the x value in an ordered pair of a y-intercept? Because we're crossing the y-axis, so what was the x value? It was 0. 2 gets the point. Here you go, ma'am. It was 0. We didn't go any left or right. We only went up, so it's 0, comma, some number. So if we want to figure out where the y-intercept occurs, we seriously just plug in a 0 into our function. And that's what that first little bit is saying. So when you plug in a 0, it ends up being just the constant term. So let's look at our first example, number 1 at the bottom. We want to know the y-intercept. If we plugged in 0, If we plugged in 0, I'm in a hurry, but yeah. If we plugged in 0, 0 squared is 0, negative 6 times 0 is 0. Both those pieces go away. Our intercept happens at 8. Every single time that happens, where it ends up just being the number at the end. So our intercept is at 0, 8. Just FYI, I'm going to fly. This would definitely be one. If you don't like quadratics, you want to watch. Okay, so we talked about the y-intercept. That's where we're crossing the y-axis. So if we were to make us a quick graph down here, we're not going to take the time to actually get our graph paper and all that jazz today. We know our intercept happens at 0, 8. So we're not really sure about how this parabola looks. Is it this way? Is it this way? We don't know, but that's one of its points. Okay, parabolas are cooler than lines. One reason parabolas are cooler than lines is something your geometry teacher would have focused on a lot. Parabolas are symmetric, meaning that if we were to get out our scissors and cut it straight down the middle, we would have a perfect mirror image on each side. They match. They're reflective. So, when I think of axis of symmetry, because that's what that where we would cut at, I think of scissors. So basically the axis of symmetry is if I had a pair of scissors and I needed to cut my parabola in half, where would I make the cut? Where would I make the cut? I kind of even think it looks like scissor lines because it does it with dots, dots, like, hey, cut me here. So to figure out the axis of symmetry, in a few minutes we're going to talk about how to do this kind of thing with the calculator. But for now, if you're wanting to do it by hand, there is, as always in math class, a formula. It's negative b over 2a. Now, you don't have to know this formula to be successful on the next test. Is it useful to know in life that the axis of symmetry is negative b over 2a? Yes. For some reason, that stuck with me better than, like, point slope. Like, it was useful. It was useful in later math classes. Okay, but before we go trying to calculate our axis of symmetry, we probably need to talk about on example 1, what form is it in?
Standard.
It's in standard form. 2 and 5 get a point. So number 1 is in standard form. And you thought standard form was never going to be useful. Standard form, ax squared plus bx plus c. We need it in standard form, yes, to plug it into this formula we're about to use for axis of symmetry. But we also need it in standard form because if it's in standard form, we can graph it with our graphing calculator. So if you run into a problem that's not in standard form, you probably should rearrange it. Your calculator can probably handle it, but would not kill you to rearrange. Okay, so for the axis of symmetry, apparently you do x equals negative b over 2a. Well, our a is a 1. Our b is a negative 6. So we end up having a positive 6 in the numerator and a 2 in the denominator. So our axis of symmetry is at 3. So if Jax, so we still haven't even graphed the parabola yet, but if Jax were to cut this parabola in half, he would cut it down the line x equals 3. Okay, so again, if you're looking at the top, it tells you we've done the y-intercept, we've talked about the equation of the axis of symmetry. The last thing we need to talk about is how to find the vertex. So if we're looking back at our picture, our sample picture, it tells you the vertex is at the very, very bottom of this parabola. So it's either your lowest possible point, or if you had a parabola that looked like this, it would be your highest possible point. And we're going to need an ordered pair for it. What's really cool, which is what the directions up here tell you, is that the vertex is happening on that axis of symmetry. So whatever number you put for the axis of symmetry, that's the x-coordinate of the vertex. So since our axis of symmetry was 3, our vertex is 3 something. We just got to figure out the something. So if our axis of symmetry was 7, our vertex would be 7 something. We would just have to figure out the something. So down here, we're trying to figure out our vertex. We know it's 3 something. We've got to figure out the something. We seriously are going to plug in a 3 into our function to see what the y value would be. So we want to know f at 3. So it used to be x squared, now it's 3 squared. It used to be negative 6x, now it's negative 6 times 3, and then plus 8. So literally everywhere I saw an x, I plugged in a 3, and that's going to help me figure out the y coordinate of this vertex. Okay, when you do 3 squared minus 6 times 3 plus 8, what number do you end up getting? Negative what?
1.
Yes, Gilberto, you can have a point. It ends up being 9 minus 18 plus 8. So it's negative 9 plus 8, which is negative 1. So our vertex is at 3, negative 1. So if I go over 3 down 1, there's our vertex. Okay, other teachers might think differently than me. That's okay. They're allowed to have their own opinions. I think in life, if you have 3 good points, you can connect the dots and draw you a parabola. How many points do we have right now? We have 2. So we're going to need 1 more good point. So we found that, does anyone have a question about intercept, axis, symmetry, or vertex? Okay. We found one of them. So we know our parabola looks kind of like this. But we would like to guess on this side. But I really don't even have to guess. I'm smart. If this one happened at 0 and the vertex happened at 3, what's the coordinates of my other point? 6, 8. Okay, so I knew they were both, there's, you know, because it's a mirror. If there's a point here, there's a point here. They're both going to be 8. The 8 should be easy to understand why they're both 8. They're both at the same height. But as for why it's 6, well, because she realized from here to here I went over 3. So from here to here I need to go over 3 more. So that's how she knew it was 6, 8. If you can find 3 points, you've got you a problem, and you're good to go. Okay, so you'd say, great, Miss Compton, we're done. No, we're not. Sadly enough, we're not even done with the first problem. It's a lot for each problem to be done. We've done part A. We found the y-intercept, the axis of symmetry, and the vertex. So check mark by A. Awesome. But as for B, make a table of values. We're going to let it go. Now, if you want to have a table of values with 0, 8, 6, 8, 3, -1, and a bunch of other points, you can. But again, in just a second, we're going to talk about how to do this with our graphing calculator. And you could always press table on there and get their table of values. So we're going to let that one go. We have kind of graphed it on graph paper. We did a sufficient job. We'll put a check mark by that. Now we're on D. We need to know whether our function has a max or a min and find that value. Before we do that, for 2 points, tell me what's different with your notes packet this time. What's different? Doesn't have the list of learning targets on the front. Nick, you get 2 points. So at the end of this, I'll have to give you a list. We don't actually have a list typed up for this unit, sadly enough. But if you were to actually, so you've not had to read the board, and you still don't have to write them down, because I promise I will hand you a list eventually. But it said, yeah, we graphed the quadratic, but the second, important thing of the day was find max and min values of a quadratic function. So, does our parabola have a max or a min?
No, because of the arrows.
Does it have a max or a min?
Yes.
What has a min?
It has a min. So every parabola can only have one or the other. Either it looks like a valley, like ours does, and it's a min, or it looks like a mountain, like our example up here, and it's a max. So if it looks like a valley, it's a min. If it looks like it's a real big hill, it's a max. And this lowest point, where our bottom of our valley is the vertex. So our min happens at our vertex. And the highest point, also our vertex, so our max happens at our vertex. So literally, once we found the vertex, it's like finding the Holy Grail, because you know all the things. So ours is a min at 3, -1. Normally when they ask max or min, they're only wanting the y coordinate, so you probably say min at -1. But if you told me the whole ordered pair, I'm not going to count off. Okay, so the min is -1. Okay, so we did part D, and now your favorite words have come back to haunt you. Part E asks for the domain and the range. If you could do domain and range of a piecewise, there's no way on God's green earth you can't do domain and range with a parabola, because it's much, much easier. Yes, dear?
So, when we do the maximum and minimum, we choose the y value?
Yes. Yes. But if you give me the whole ordered pair, I'm not going to count off.
Okay.
Domain and range, your favorite words come back. You knew they wouldn't go leave forever. How do we figure out the domain? I'm reaching out from the x-axis. Is there anywhere where I can't reach out and touch my function? So what am I going to say for the domain?
All no numbers.
No, infinity.
We did negative infinity to infinity, yes. No. Needs to be an interval notation. Now here's the great thing about parabolas. From here on out, there are always exceptions to every rule. So this is 95% true. Let me say that first. If it's a real world problem, they might restrict the domain, but anyway, 95%. Just as like to 95% odds. That's pretty good. 95% of the time, domain with a parabola, negative infinity to infinity. Always. Always. 95%. Now, and the other 5% is for some weirdo real world problems. The range is the only tricky part. We've got to figure out when can we reach out and touch our function from the y-axis, and no, the answer is not negative infinity infinity. At some point we started touching it, and then we kept on touching it forever. When did we start touching it? We started touching it at -1, and then we kept on touching it forever. We reached out and touched it at -1. We couldn't reach out before -1 to touch it. We started at -1. Since we could physically put our finger on it at -1, we're going to put it in the bracket. So it's -1 to infinity. The range is always going to be trickier than the domain. It's going to have an infinity somewhere. It might be -1 to infinity if it's a min. If it was a max, it might be negative infinity to 30. Like it's not going to necessarily always be number comma infinity. It could be the other way around. Are there any questions about number 1? Then flip to the next page. We're going to make number 2 much, I would say, easier, but we still have to go over how to do it. So much shorter, yes. No one is going to be mad at you if you want to continue to calculate things by hand. No one, especially not me. I think that would be awesome. For instance, before we even graph this, I already know the y-intercept. What is the y-intercept on number 2? So I know it's 0, 6. So you see, some things are so easy, you don't need to graph, you don't need anything but your brain. But as for that axis of symmetry, and the vertex, and, I still got to know the min or max. I've still got to know the domain and range. I can guess one more of these things. What other things should I go ahead and guess? Huh? Say it again. Yeah. I'm telling you, 95% accuracy. Daniel gets a point. So yeah, we actually need to calculate axis of symmetry, vertex, min, max, and range. Might help if we actually, graph the quadratic function and looked at it. But there are some parts that I don't even have to graph. I just know instantly. So on number 3, I would go ahead and guess 0, 5. My domain's negative infinity, infinity. Okay. How to put this bad boy in your calculator. Press Y equals. It's up near the top.
Miss Compton?
Yes, ma'am.
Hey, was Tony Bivens in first period this morning?
No, ma'am.
Thank you.
One day, I'm going to do it all. Today was not that day. Okay, so we need to graph negative 5x squared minus 10x plus 6. And sadly, which buttons we press are going to affect our graph. So when I say negative 5x, which negative button do I press?
Not the minus button.
Not the minus button, the negative button. So negative 5. X is the button that has the x, t, theta, n. So I've got negative 5x. Anyone not have negative 5x that's trying to graph? Again, I did negative 5x. Yeah, I can't make you see my screen and this at the same time. One is only so good. Okay, then minus 10. So minus 10x plus 6. So plus 6. And now I look and look, negative 5x minus negative 5x minus 10x plus 6, and I've done something wrong, haven't I? It's supposed to be negative 5x squared, so if I scroll back over, I can fix that. It's supposed to be negative 5x squared. There's actually a button that says squared. Now, oh, Miss Compton, I did the thingy squared instead of 5. Let me start over my life. Negative 5x squared minus 10x plus 6. Okay, so you know how you press the negative 1 button for inverses? The x squared button's right below it. Negative 5x squared minus 10x plus 6. So we've typed in our equation. Now, if you don't type in the equation right, everything's going to go wrong from here. You press graph, and then your graph may or may not be ugly like mine. It all depends on your zoom. It all depends on your zoom. So press the button that says zoom. So normally, I like zoom standard. Zoom standard is like a normal 10 by 10. But sometimes zoom standard stinks. It does with this one because our vertex is off the screen. So zoom standard didn't really work. So we can zoom out and say specifically, like, I want to zoom out and I want to focus on up here. You can tell it to zoom out, but I don't really like that either. To be honest with you, how I normally zoom is the ugly picture we saw to begin with. If you press zoom and you keep scrolling, there's a button that says zoom fit, and I normally like to pick it. Zoom fit is supposed to fit your graph. Now, zoom fit stinks for this specific picture because now it looks like it hits the y-axis just so. I mean the x-axis just so. So it's not necessarily a great picture, but it does graph. So basically, if you're hating on that picture, you should probably zoom standard and then zoom out. So if you're mad at your picture, press the button zoom. Get it how you want it. Because there's a zoom box. There are lots of them. I'm going to zoom out up there. There are lots of them. So, I'm going to go back to standard, because that standard's really not bad. When we zoom standard, yeah, we can't see that vertex, which is kind of a bummer. But we can see for sure that that intercept happens at 6. And in fact, of course, you're like, well, I can't actually tell that. How do you know? If you press the trace button, you can literally trace the different points. So it told you, at 0, my y is 6. So 0, 6 is for real. Okay, but there's also another button we're going to press. But before we go there, we already know one of these answers. Is it a min or is it a max? We know it's a max. We just need to know where it's at. We're going to need the vertex, but I swear, once we know the vertex, we know the max, the range, axis of symmetry. So as long as we don't mess up the vertex, we have the rest of it made. So we can zoom, and I'm going to show you a different button in a second, but you can always, we talked about making a table of values, you can always look at your calculator's table of values. So press second, and then table, to look at a table of values. Now, with a table of values, so second and then table. Second and then table gets you a table of values. It's in blue above graph. Everyone got second table?
I got it.
Okay. Now, what's cool with your table is that you can scroll up or down. Oh, it looks like I'm getting bigger and bigger. Now, you told me it was supposed to be a min or a max. Which one is our graph? A max. So I'm looking to see the highest number possible in that Y1 list. What's the highest number you see in that Y1 list? Yeah, the highest thing I see is the 11. The highest thing I see is the 11, which makes sense because that would be where that max is happening. And that max is at the vertex. So my vertex is negative 111. So again, I used my calculator. I went to second table after I've graphed it. Because I didn't think I was getting much from the graph. We'll talk about how to make the graph work for you in a second. But I want to show all the options in life. So I went to second table. I knew it was supposed to be a max. So I was looking for the highest number over here. and the highest number I could find was an 11. So there's a max at 11, and then the vertex is at -1, 11, and then that axis of symmetry must be -1. Seriously, once you know the vertex, you know where the max is, you know the axis of symmetry, and heck, you even know the range. Because you know it's going to be -infinity until you hit that max of 11. So literally, once we knew the vertex, we knew the rest. So if Justice types it in wrong, messes up the vertex, he messes up the rest. Okay, there's also a potential issue with your table. Why would we not want to trust this? I think it's right on this one, but why should we question the table? What if you have a decimal fraction? 2 gets another point. What if you have a decimal fraction? This is only doing whole numbers. So you can, if you want to be fancy, there's a button that says table set. So you can press second table set. When you get to table set, you're actually now in control. So you can tell it what number to start on. That's what table start means. And then the little triangle table means delta table. So you're telling it how to count. Right now it's counting by 1. So 1, 2, 3, 4, 5. But if Cassidy wants it to count by halves, she can tell it count by 0.5, 0.1, point whatever. So if you're wanting it to give you decimals, it can. It's that good. But again, there's a better way. Okay, so if you did that, you would have to press enter and then go back to second table. And now, lo and behold, it's changed. But hey, it still says -1 11 is as high as we're getting. So we were right to bank on it that time. Okay, so press graph again and go back to graph. I'm going to do that ugly zoom, the zoom fit, just because I feel like that helps us figure out that vertex a little more. So we think it's at -1 11, but we really would like to know. So we can actually, we've messed with, we never really messed, so all the blue keys. I'm looking at the blue keys at the top. Stat plot, you're not into AP statistics. You're never going to press that. We talked about table. We talked about table set. Format, I never really get to mess with either. I don't even know what second format does. Oh, that's cool. You could turn on your, like if you wanted to see the whole grid, you could turn that on. So when you press graph, it would actually show all the things. Now, why you want to see that, I don't know. So I don't normally mess with format, but that's cool. I didn't know you could do that. Okay, so, but the one button we hadn't pressed is calculate. So if you want to press second and then calculate, come on, graph, let's cooperate. That's one thing that stinks about the calculator. Once you press graph, it will graph it, and you can't do anything else till it does. If you press second calculate, we've got some options. And honestly, once you learn how to operate second calculate, you really don't have to use your brain anymore because it's going to do all this stuff for you. For instance, if we wanted to know a specific value, like we wanted to make sure that the intercept was at 0. So you could say, if x is 0, what's y? Oh, it's 6 for sure. Or second calculate, because maybe AJ's wanting to graph some more on his paper. So maybe he wants to know when x is 1, what is y? Oh, it'll tell you. Y is -9. But more than that, it does other things too. Like it can tell you a specific 0. But since we're trying to find a maximum, and we know that max happens at the vertex, we can seriously tell it to find the max. So if you press second calculate and then max, you get to this, and it says left bound question mark. Is there anyone here who's lost? Okay, so left bound question mark seriously means we assume our thing happened here. We're going to go a little to the left, press enter. Then it's going to say right bound. We're going to go a little to the right, press enter. It says guess. It doesn't matter where you guess as long as you guess in between. And then it'll tell you the right answer. Now, the reason it makes you set bounds is because quadratic functions don't have more than one min or max. There are other functions that do. So I set it a little to the left, a little to the right. I make a guess, which is terrible. And then it tells me your actual maximum is at -1 11. Oh, cool. That's what I thought anyway. So, again, we can calculate it because we learned a formula. We can look at the table and figure it out and pray it's correct. Or if you do second calculate, You can literally make it figure it out for you. Second calculate is always going to work because if it happened to add a decimal or a fraction, like Daniel was saying, it's still going to get it right every time. Okay, any questions about this? We're going to do number 3, and we will call it a day. I need the answers to number 3. I'm willing to give a point per answer. Ellie, you get a point? I wondered why no one had answered that. You get a point. Why don't you answer the other obvious one too, Jax? Thank you, Nick. Another point for you. No one's got that vertex or that axis of symmetry? Yes. You can have a point, Gilberto. What's the axis of symmetry then? You can have another point. And then, so our min happens at... You can have another point. I'm telling you, once you've got the vertex, you've got it all. Why don't you tell me about that range? Daniel gets the point. Okay, so seriously, I pressed graph on my calculator. I got a graph that looks like this. I don't know about you, but I looked at the table. And I made sure that he wasn't crazy. 2, -3 was as low as it went, so for sure that was the min, which means the axis of symmetry was at 2, which means that, everything else just fell into place from there. But you could also second calculate and make sure that vertex really was at 2, -3. That would be genius of you. We're going to pick this back up tomorrow. Sadly, there's more to do with quadratic. It's going to be a very busy time. I can go ahead and tell you there is a quiz on this on Monday.